the last problem that we're going to do for determining the rate law and the rate constant is this problem here. So boron trifluoride plus ammonia gas goes to form the F3B NH3 complex. And so again, it wants to know what is the rate law for this reaction and what is the rate constant for this reaction. So as you can see, we have more than the typical 3 experiments for this reaction, which is why I chose this one. But we're going to do the same process as we did in the other one. So I have basically one compound and a second compound. So the way I'm going to do this is I'm going to say for my BF3, what are the possible reactions? So basically I'm looking for which ones are different. Okay, so basically 3 of them are different, but I'm going to list all my possibilities. I could have 1 and 3, 1 and 4. I could have 2 and 3, 2 and 4. Okay, so 1 and 2 are the same, and so I went these 2 and these 2. So if I start at the top, and then this one and this one and this one and that one. Those are my 4 possibilities. So these are the ones that are different. And just like the same other process, I'm going to go back and check and see which ones are the same. So if I look at 1 and 3, is 0.1 and 0.250 the same? No. So I cannot use this one. I look at 0.25 and 0.1. They're not the same, so I cross that one out. I look at 2 and 3, 0.125 and 0.1, not the same. And so the only one that is, oh, I didn't even put this possibility. I put down 2 and 4, which isn't, okay. But I just realized I didn't put the last possibility, which is 3 and 4. And those 2 are the same. So this is the one that I'm going to use, okay. Same setup as before. I want the highest concentration on top. So I'm going to use these 2 right here, and these 2 rates right here. Okay, and I want the highest concentration on top, which is number 3. So I have the concentration of BF3 for number 3 over the concentration of BF3 for number 4, and that's to the M, is the rate for experiment 3 over the rate for experiment 4. Again, I want to make sure that these 2 numbers are the same. 3 and 3 are both on top, 4 and 4 are both on the bottom. And then I plug in my numbers. So I have 0.350 divided by 0.175 is going to be 0.1666 divided by 0.0417. So when I divide 0.3 by 0.175, I get 2. When I divide 0.166 by 0.0417, I get 4, and that's 2 to the M. So what power of 2 is equal to 4? And the answer is 2, so M is equal to 2. So I'm done with the BF3. Now I'm going to do the NH3, and again I'm looking for the ones that are different. Okay, so I could do 1 and 2. So 4 NH3. I can do 1 and 2. I can do 1 and 3. I can do 1 and 4. I can do 2 and 3. And I can do 2 and 4. Okay, 3 and 4, which would be the next one, is not any different. Okay, so these are all the ones that are different, and now I'm going to see which one will allow me to be the same. So now I'm looking at this column. So if I look at 1 and 2, they are the same, so that one works. 1 and 3 are not the same, so that one would not work. 1 and 4 are not the same, so that one doesn't work. 2 and 3 are not the same, so that one doesn't work. And 2 and 4 are not the same, so that one doesn't work. If you have multiple ones that work, you can choose which one to use. But in this case, it's 1 and 2. So I'm going to be using these numbers. And then the rates that correspond to that, so these numbers. Again, the highest concentration goes on top, which is 1. So it's going to be the concentration of NH3 for experiment 1 over the concentration of NH3 for number 2. And this one's to the N because it's the second one I'm doing. So the rate for experiment 1 over the rate for experiment 2. I plug in my numbers. I have 0.250 divided by 0.125 to the N. The 0.2130 divided by 0.1065. And if you want to know where I'm getting these numbers, all these numbers are coming from the table up here. So just locate them. So 0.25 divided by 0.125 is again 2. That's the most common one to double the concentration. 0.2130 divided by 0.1065 is also 2. So what power do I raise to equal 2? And so N is equal to 1. So my rate law for this reaction, the answer to the first question here, what is the rate law? The rate law is going to be rate is equal to K. So every equation has the K times concentration of BF3 squared divided by NH3. And I don't have to write the 1, so I'm not going to. So we've answered this question. Okay. And second is, what is the rate constant for this reaction? Okay. So, don't need that. Oops. Now, I'm going to go ahead and erase some of this stuff. I don't want to erase all the ink, so I'm going to use, it's going to take a second. Yeah, see, I can't do that. Just curious. No. Okay. So to do the K, I'm going to use, so for experiment 1, I use the rate, so I'm plugging into this equation, so it's 0.2130 is K times the concentration of BF3, which is 0.250 squared. So I'm using this equation, except I'm just putting in numbers, and 0.250. So I have 0.2130 is equal to 0.1563 K. I divide both sides by the 0.1563, so 0.2130 divided by 0.1563 is equal to K. And so K is equal to 13.6. Okay, and if I do this for, so I'm going to say K2, it was also 13.6. And since these are exact numbers, I'm going to assume that they all equal the same thing. You can go back and practice these. And K for experiment 4 was also 13.6. Okay, and so I did these, each one of these, by just plugging in the numbers for each line here. Okay, so to practice these problems in the book, number 53, 55, that's it. Oh, and I'm sorry, 51, 53, and 55 are problems like this in the textbook.